Okay, so I'm going to flip into my notes here. We'll do AB, the AB, because remember it could be on your test. You guys have seen the test, so you kind of know what's there. We'll do AB 1, 2, 3, and then we'll do the BC 3 because it's the same stem, and then we'll flip to the back side. Okay? And I didn't put out ones for tomorrow, but I'll put those out as soon as we're done here. So that way you guys have them. Okay. And you can start working on them because I think I'm going to go earlier. I think I'm going to go at 11 tomorrow. That's what fits in my calendar because we have to watch Star Wars tomorrow. So last week we watched episode 4, but we're watching them while the babies are at daycare. So tomorrow we have to watch episode 5. Oh, here comes Maribel. Hi, Maribel. We're going to, since we only had BC people here, we were going to do a little bit of AB and BC. You didn't mean to join. Okay, I'm sorry. Well, it was nice to see you. All right, we'll just keep going through. All right, so we have the functions differentiable on a closed interval consists of 3 line segments. The figure shown is known that f of 4 equals 14. And what open intervals is f both both decreasing and concave down. So what do I need to do?
Sign chart.
Sign chart. Okay, so let's do sign chart. Because again, it could be on the AB, it could be on the BC, it could be on both. So I know I need to do a double layer sign chart even because it's got to be because it could be first derivative, second derivative because it's talking about decreasing and concave down. So when I see that, I want to grab every single zero and horizontal tangent that I see. Okay. So what's the first number I'm going to put on there?
Or wait, because the graph is already of f prime, does that mean you're taking the second derivative first and then the third derivative, or do you just?
No, I'm just going to work off that graph.
Okay.
Okay. So what number am I going to grab first?
-2.
Yep. Okay. And then what am I going to grab next?
Would you choose 0 or no?
No, because 0 it's not doing anything there. It's not a 0 and it's not a horizontal tangent.
So then it would be 1.
1, good. All right, what's next?
7.
7, yep. I agree. Okay, what else?
9.
9, and where am I going to end?
12.
12, perfect. Okay. So I'm first of all looking at, because I'm looking at the graph of the derivative, so I'm going to look at what's above and what's below. And then I'm going to look at the increasing and decreasing for that part there. Okay. So above the graph, so it looks like what's going on first? Am I above or below?
Above.
Above. And then what happens to the rest of them?
It's all below.
It's all below. Okay. And then for the second derivative, so what we do is we look at the slope on the derivative graph. So we need to know if it's increasing or decreasing. So what's going on first?
It's decreasing.
Decreasing, and then what?
Decreasing.
Decreasing, and then?
Increasing, and then?
Increasing, and then?
Decreasing.
Decreasing. Okay, so then it said we needed decreasing and concave down. So we want to look for a negative situation. So there's our 2 intervals. You want to probably say something about, I guess we just need to say, so we just need to make a statement about it. F is decreasing and concave down. And of course, you write out the nice words on, and then you just do the open intervals 1 to 7. You can use the union symbol. You can use the word and 9 to 12. And it doesn't say, it does say give a reason. They didn't give a reason for their answer. Or the way they gave it was kind of weird. Okay, so because f prime, because we only know about f prime, because that's what the information they give us. So because f prime is negative and decreasing on these intervals. Okay. Sound good?
Mm-hmm.
Okay. Trina, you let us know if we're missing something for you. All right. So looking at part GEE, okay, number 2, let g of x equal f of x times f prime of x. We got to find g prime of 4. What do I need to use?
Product rule.
Product rule, good. Okay. I'll do it the BC way for you guys. It's up to you. Do you want me to use the red and the green, or do you want me to do it keep the first or the second?
Keep good old BC way.
Okay, the BC way. Okay, so I'm going to keep the first. Okay. And then the derivative of the second would be f double prime of 4, or sorry, of x, not of 4. Okay, then what's the second half look like?
F prime of x times f prime of x.
Yep. And then what do I have to do?
Slap in a 4.
Yep. So g prime of 4 equals f of 4 times f double prime of 4 plus f prime of 4 times f prime of 4. All right, so now I got to look for stuff, and there was something I missed totally in that beginning of my problem. Look at that.
The initial condition, yeah.
Yep, so that's got to go in there, so 14. How do I get f double prime of 4?
You read the slope off the graph?
Yep, read the slope off the graph, good. So it looks like we're going down 2 and over 3.
Yeah.
And then we got to read the actual y value off the graph for the f prime of 4, which looks like -2.
Mm-hmm.
Then stop and don't do anything else. Good?
Yep.
Okay. All right, so for AB3, we have to evaluate so I'm going to integrate it. I'm going to go ahead and choose to split it into 2 integrals. So I'm going to integrate 3 dx minus 2 times the integral of f prime of x dx. And this is definitely an AB level type of integration. You guys would probably have done they would have done parts or something in here. But this doesn't hurt. I'm sure that Uncle Brian's materials will include integration by parts somewhere in the next couple of days. So we'll get it all in. All right, what do I get when I integrate 3?
3x.
3x, good. And when I integrate, I'm going to keep the 2. When I integrate f prime, what do I get?
Just f of x.
F of x, good. And we're going to go from -2 to 12. It depends. It doesn't matter how you do that. I guess I really didn't need to separate it, but I chose to. It's a -2. All right. So I've got 3 times 12 minus 3 times -2 minus, and then a parentheses, 2 times f of 12 minus 2 times f of -2. Okay. Oh, I shouldn't have done that. Okay. Totally need to go back.
Bad.
Why do I need to go back? Do we know what f of 12 and f of 2 are?
No. That's a yes. What do we?
Yep. So we did. That's why I did need to split it, because I could integrate this first piece, but this back piece, I just needed to use the whatchamacallit. So when you're taking the test and you see that and you mess up, don't erase it. Just whatchamacallit. Just cross it out and move on. Okay. Takes too much time to erase. Okay. So 2 times. I'm just going to keep the integral and we'll do it again. Sorry about that. We're going to use the area formulas. So 3 times 12 minus 3 times -2, just like before. Now we're going to go back and we're going to look at our graph. We're going to look between -2 and 12. So between -2 and 12, we have a triangle. Oh, that's an ugly color. And a triangle. I changed it during trig today. All right. So, and all I really have to do is get these area formulas in there and we're done with the problem. So what's the base of this first triangle?
3.
3, and then the height?
4.
4 divided by 2, plus, okay, what are the dimensions of the next one?
8 by 4.
I'm seeing 7 by 4.
I might.
Double check.
Am I special? I'm counting eight.
It starts at 1 and goes, oh no, you're never mind. I'm
Okay.
special apparently. So it's all me being special apparently. I can't count. All right, so it's 8. Okay. What's wrong with what I have right now though?
Oh, it's assigned area, so you need to slap a negative on that one.
Yeah. Okay. So negative in front of it. And make sure if you're not going to calculate it, that looks terrible. You got to make it clear that that's actually a negative sign. Okay. And then our last little triangle.
Oh, 3 by 2.
3 by 2. So plus 3 times 2 over 2. And then again,
negative. Yeah.
Negative. And don't do anything else. Stop right there.
Sweet.
Okay. All right. People are having trouble getting into Power School today. It's driving me bananas. Okay. Let's go try the other part of this one. So let's do the BC now. So we're going to do BC3. It's the same stem, but different problem. So they want us to find the average value of f double prime of x over the interval. So what do we have to do for average value?
That's something with an integral, right?
Yes. One over. Sorry. We're doing the lesson.
Is that the
1 over what?
The initial condition?
No. Your average.
You have to discuss this. Thanks, Ellie.
You said it too. Say no.
Yeah, see, I was getting there.
Uh-huh.
Mm-hmm.
Okay. So 12 minus negative 2, right? Okay, you can't touch any buttons right now, sir. Okay, say bye. Say bye. Can you blow kiss? Blow kiss to everybody. Oh, thank you. Thank you for the kiss. All right. From negative 2 to 12. And then of whatever this function is, f double prime of x dx. All right, so what are we getting? 1 over what?
16. 14.
Thank you. All right, oh joy. Here comes the other one. One, you can blow one kiss. Oh, hold on.
Don't drop them again.
I won't drop them again. Okay, blow one kiss. Blow a kiss. Blow a kiss. Blow a kiss. Do a kiss. There you go. Love you. You got to go with Dad. I'll be out in just a little bit. Okay. Go help Daddy make dinner. It smells good. Okay. So, I'm integrating. I shouldn't be integrating. Okay. So we've got to do parentheses. And what do I get when I integrate f double prime?
Just f prime.
Yep. F prime of x. And we're going to go from negative 2 to 12. All right, so 1 over 14. And notice how I just almost lost that 4, or lost the 1, so you got to be careful. Let's see. F prime of 12 minus f prime of negative 2. And then what do I have to do to get those?
Just read them right off the chart?
Yep, you read them right off the chart. You're right. So what are we seeing for 12?
Negative 2.
Yep. What are we seeing for negative 2?
0. No. Yes. 0. Right?
I'm seeing 4.
Oh my gosh. Yeah.
Negative 2. Got to read the y value off. Okay, just making sure.
Yeah, no, I was just checking you.
Stop and don't do anything else. All right. They're not happy about having to leave. Okay, let's go back to that other stem, the tabular stem. Okay, so now we're going to do AB4, AB5, and then we'll do BC5, because BC and AB4 are the same problem. Mm-hmm. All right, so consider the differential equation. dw d over dt equals 9 minus w squared. Let y equal w of t be the particular solution to the differential equation with the initial condition. So we've got a nice initial condition again. The function w is twice differentiable with selected values of w given in the table above. We got to find the second derivative. So we're just going to have to power through second derivative, right? So d squared w over dt squared, right? Or second derivative equals, what's the derivative of 9?
0.
Okay, derivative of negative w squared.
Negative 2w.
That it?
Oh, dw dt?
Yes.
Okay.
Good. Okay. And on this particular thing, you have to probably substitute back in for the dw dt. So you need to rewrite it as, I don't know, I'm just going to go equivalent. Negative 2w, and then we're substituting this guy back in, the 9 minus w squared. So you got to be careful on that one, okay? But again, you've been away from it for a week, right? So you got to get your sea legs back on, okay? All right. You good with that one? That's it on that one.
Oh,
And the other key was making sure you went back and read this, right? It says it's explicitly in terms of w, so you couldn't leave the dw dt. All right. You guys had a midpoint sum, right?
Yeah.
All right. So midpoint sum with 3 subintervals indicated by the table above to approximate. And I should see the papers on Tuesday. I'm supposed to get them all.
Oh, sweet.
Not yours if you didn't submit, but
Oh.
but I'll see everyone else's, and I'll probably have the problems, so we can look at what you were doing on it. So, all right. The midpoint. So we've got 1, 2. Oh, that's not 2. 2, 3. All right, 0 to 1. Okay, I'm liking it. So we're going to have, and you can rewrite that to be proper about it. Equals, and we know we got 3 subintervals, and I have to do distance in between and height. So what's my first distance in between?
0.4.
Yep. And then what height am I going to use?
5.7.
Good. And then my next distance in between is?
0.2.
My height is?
12.2.
Excellent. And my distance in between is?
0.4.
Good. And my height is?
29.3.
Excellent. And don't do anything else. Stop.
Nope.
Go get credit for that. Okay.
All
right. I'm going to go over to the BC prior to the problem. Hopefully no one was going to come just for BC. It's too late now.
Yeah.
All right. They'll have to watch the video. All right. So we're supposed to write but not evaluate an integral expression in terms of w and t that gives the arc length of w of t. So what is the formula for arc length?
Square root of 1 plus the derivative squared.
Equals square root of 1 plus the derivative squared. Good. And did you have that memorized, or did you read it off your notes?
No, I had that memorized.
Good job.
Sweet.
How much did you even use your notes during the test?
Not that much.
Not that much?
No.
All right. See, you had to know it because we almost didn't have time. All right, we got to integrate this thing. So we're going to integrate from where to where?
The 1 to 3.
1 to 3, good. And then the square root of 1 plus, all right, and then do we know the derivative?
You gave it to us like wait, technically, yes?
This is the derivative, isn't it?
Oh, yeah. Wait, why'd you do f prime of... Oh, wait, no.
Because I was just writing a general formula.
Yeah.
I should have written w prime of t, right? To be in context of the problem. That wasn't part of my work. I was just refreshing our memory on the formula. So 9 minus w squared, and then throw a dt after it because it was in terms of t. That's it. Done. Okay, we handle it? So what I will do is he didn't put out like in order days. There might be a day 5, but then he kind of skips around on numbering it. So I'll put the next one out. My plan is to do this at 11 tomorrow morning. So you got to try to get it done, but you need to do it beforehand.
Mhm.
Okay. So try to do it before 11 tomorrow. And
What if they change it a bunch?
what if they change it a bunch? What do you mean?
Like, what if the college boards are like, oh,